Hello everyone. Today I am going to explain the topic that is queue. Queue is a linear data structure which allows insertion of an element to be done at one end, that is the rear end, and deletion of an element to be performed at the other end, that is the front end. Now, real life example of a queue can be any queue of customer waiting for some resources, for example ticket or anything else. So the customer that came first will be served first, and the customer that came last will be served last. Now, queue data structure follows first in first out order. So the element that has entered first will be removed from the queue first, and element that has entered the queue just now will be removed last. There are two main operations that can be performed on queue. They are enqueue and dequeue. Enqueue means adding an element to the queue. Now addition of an element in the queue happens at the rear end. While adding an element to the queue, we must check the overflow condition. Overflow condition means we have to check whether the queue is full. If the queue is full, we cannot add another element to the queue. Similarly, in dequeue, we remove an element from the front end of the queue. The elements that are removed in same sequence in which they are added. And while removing an element, we have to check the underflow condition. Underflow condition means we have to check whether the queue is empty or not. If queue is empty, we cannot delete an element because the queue is empty. It does not have any element. Now we will see the algorithm of insertion of an element in a queue. First, we will initialize front and rear with -1. Next, we will check the overflow condition. If r is equal to max minus 1 and max is the size of the queue, then we write overflow and exit. If r is equal to max minus 1, that means the queue is full and we cannot enter another element. If f is equal to -1, we will set f is equal to 0. Then we will increment the value of rear by 1, that is r is equal to r plus 1, and we will insert the item at that rear in the queue, and then we will exit. Now we will see the algorithm for deletion of an element from the queue. First of all, we will see the underflow condition, that whether the queue is empty or not. If queue is empty, we cannot delete any element because it does not have any element. So if f is equal to -1 or f is equal to rear end, we write underflow and then exit. Then if the queue is not underflow, then we will increment the value of front end and then exit. Now let's see an example of queue. There is a queue of size 5 and we have to insert 27, 19, 17, 7 in it. Size of the queue is 5, so value of max is 5. At initial stage, f, that is front and rear, will be -1. We will now add 27 to the queue. Following the algorithm of insertion of an element, we will first check that whether the queue is full or not, that is the overflow condition. We will check if r is equal to minus 1, but initially r is minus 1, so it is false. We will set the value of f to 0, and then we will increment the value of rare by 1, that is minus 1 plus 1 is equal to 0. Now at 0 index in the queue, we will add the item, that is 27 in the queue. Resultant queue will look like this. At index 0, 27 is added. Now we have to add another element, that is 19. So again, we will check first the overflow condition, that is r is equal to max minus 1. But we know that r is equal to 0, and this second condition is also false because we have earlier set f is equal to 0. So directly going to the third condition, r is equal to r plus 1, that is 0 plus 1 is equal to 1, and we will add the item 19 at the index 1 in the queue. So resultant queue will look like this: 27 at 0 index and 19 at 1 index. Similarly, we can add the remaining items, that is 17 and 7 in the queue with the same methodology. The resultant queue will look like this: 27, 19, 17, 7 at the index 0, 1, 2, 3. After seeing the example for insertion of elements, we will now try to delete the element that we have inserted earlier in the example. Now we have to delete 27 and 19 from the queue. Resultant queue, as we saw earlier, looked like this. In this queue, front is pointing at the 0 index and rear at 3rd index. Now for deleting the 27, we will first check the underflow condition. We will check whether queue is empty or not, but we know that queue is not empty and f is equal to 0. So this condition is false. We will shift 27 from 0 index of the queue to the item, and we will simply increment the value of f, that is f is equal to f plus 1, 0 plus 1 is equal to 1. Then we will exit. The resultant queue will look like this. 0 index is deleted, so front is shifted to 1 index and rear is unchanged. Next, we have to delete 19. So again we will check the underflow condition, that is f is equal to minus 1 or f greater than r. But as we incremented f by 1 earlier, we know the value of f is 1. So we will shift the value from 1 index, that is 19, to the item, and we will again increment the value of f by 1, that is f plus 1 is equal to 1 plus 1 equal to 2. Resultant queue will look like this. Front is shifted to 2 index, it will point to 17, and rear is unchanged at 7. Implementation of queue can be done in two ways: implementation by array, implementation by linked list. Now, the example we saw earlier use the implementation of Q by array. We took the array Q and did the operation of NQ and DQ. Now we will see the implementation of Q by using linked list. Now we should get the question that why we should use linked list implementation of Q. What is bad in array implementation? So there are few limitations to array implementation, which are if we have a queue, any queue, circular queue, linear queue, that is full, and if we have to add another element to it, we cannot. We have to take a larger array and copy this data there, which will take much time. In another scenario, much of the spaces sometimes remains unused, and we should never waste memory. So to overcome these limitations, we use linked list implementation of Q. Now we should get a question that why are we using linked list implementation? What is bad in array implementation? So there are limitations like if a queue is full and we have to add another data element in the queue, then we have to take a larger array. As you can see, the queue is full, and if we have to link the list implementation of queue. Now as we know, queue has only one property, that the element which enters first is removed first. Queue can be implemented in linked list like the value of queue can be set as the argument value, and the addresses of the node can be stored in the next. Now as you can see, I have set the head of the linked list as front and the tail as rear. Now we will see the main operations that we performed earlier on linear queue. We will see how they are implemented in linked list. First we will try to add an element, that is 26, to this arrangement. First of all, we will check whether the queue is full or not. Then we will create a node, add 26 to its argument value, and set its next value to null. In the next step, we will set the rear next to the new node. In the last step, we will remove this link and set it to the new node that we have created. Now we will see some applications of queue. Queue is used when things don't have to be processed immediately but have to be processed in first out order, like BFS, that is breadth first search. So queue can be used in scenario like when a resource is shared among multiple consumers, such as CPU scheduling and in disk scheduling. Another scenario in which queues can be used is when data is transferred asynchronously, that is data not necessarily received at the same time as sent between two processes, that is between by file IO, pipes, IO buffers. Queues can be used as a data structure. Let's see the types of queue. There are basically 4 types of queues. First, that is simple queue that we have seen. Simple queue with front end and rear end. Other 3 types of queues we have to discuss. So let's discuss circular queue first. Now we can ask a question that why we need circular queue. We have a simple linear queue, then what is the need of circular queue? Now see this scenario. We have a queue of size 5 and it is full at the moment. Now we delete 10 from the index 0. So front is pointing at 20 at index 1 and rear is pointing at 50 at index 4. Now if we have to insert 60, we will first check the overflow condition according to the algorithm. We check that whether the value of r is equal to max minus 1. Value of r is 4, so it is equal to max minus 1. So we will get overflow. But we can see that there is a space where we can insert 60. So this is the disadvantage or the limitation of linear queue. We cannot go back to index 0 and insert 60. Due to this limitation, we have to use circular queue. Let's discuss circular queue. Circular queue is a type of queue where all nodes are treated as circular. That is, last node is connected back to the first node. So due to such type of structure, it is called ring buffer. That is, the last node is connected back to the first node. So it makes a ring-like structure. So it is also known as ring buffer. Now this has an additional advantage that any empty space at the beginning can also be filled using the rear pointer. Talking about rear pointer, let us discuss the insertion and deletion algorithm of circular queue. Now, for inserting an element in the circular queue, first we will set the value of rear to rear plus 1 mod n, where n is the size of the queue. We do this so if rear has reached to the end of the queue and we have to set it to 0 index, then rear plus 1, that is 7 mod 7 will become 0. So rear can get to the 0 index to fill it. Next we will check if front is equal to rear, that is the overflow condition. If front is equal to rear, then queue is full. Then we have to exit. Otherwise, we can insert the item at that rear position in the queue. Now, after discussing circular queue, let us discuss priority queue. Now, priority queue is a queue in which elements are having priorities. Often the items added to the queue have a priority associated with them. This priority determines the order in which they exit the queue. The highest priority item is removed first. That is, the priority determines the number in which they will exit the queue. If priority of two elements is same, then we will follow FCFS order, that is first come first serve. Now a real life example of priority queue can be you are standing in a queue for some resource and a VIP enters the queue, then he will get the resource the first, and you are standing in a queue, but you have come before the VIP, but you will get the resource after the VIP gets the resource, because the priority of VIP is more than you. Now, thinking of a technical example, we can assume a operator's console that gets many routine messages but all possesses low priority. However, if something fails, an interrupt or alarm message is sent, then they have high priority as some action is required immediately. Now, there are three main types of operation that can be performed on priority queue. First is inserting an item with its priority value. Insert item priority. This operation inserts an item with its given priority. Second is getting highest priority. It returns highest priority item. And the last operation is deleting highest priority, which removes the item with the highest priority from the queue. Now let us discuss DQ, that is double-ended queue. Now, double-ended queue is a generalized version of queue data structure that allows insertion and deletion at both ends. Now, we should get a question that why we need DQ. Taking a real life example, consider a ticket line, and if a ticket line is too long, suppose there are 20 people and if one person comes, stands for some time and thinks that his number will not come, then he may leave the line. In another scenario, if there is a line that is very long and you are in emergency, then you may go to the first person standing on the line and request him to let you buy the ticket because you are in emergency and your train is about to leave. In these both scenarios, the insertion and deletion are happening at both the ends. Structure of DQ is somewhat like this. Their insertion and deletion are happening at both the ends. There are four main operations that can be performed on DQ, that is insert front, insert at last, delete at front, and delete at last. Finally, we have reached at the end of this video. We discussed many things in the video, like we first of all discussed introduction to a queue. We saw what is queue, what operation can be performed on queue, what are the applications of queue. Then we saw implementation of queue in two types, that is array and linked list. Then we also saw different types of queue like circular queue, priority queue, and DQ. Thank you.